Section 5.3, Basic Concepts of Polynomials. A monomial is an expression that is the product of a real number and variables raised to non-negative integer powers. List 4 monomials. 4x is a monomial. 1/2 x squared is a monomial. 3x to the 5th is a monomial. 2x cubed is a monomial. The following are not monomials. Explain why. 3 divided by x, that's not a product. It is a quotient. 2x plus 5, that's not a product. It is a sum. 10x to the negative 3, look at that exponent. Negative 3, we're supposed to have non-negative integer powers. So the exponent is negative. That's why it's not a monomial. Monomials are the building blocks for polynomials. A polynomial is an algebraic expression with one or more monomials added or subtracted. List 3 polynomials. 2x plus 7. That's a polynomial. It's a sum of 2x, one monomial, and 7, which is also a monomial. 3x squared minus 7x plus 1. That is a polynomial. X squared minus 2. That is a polynomial. The following are not polynomials. Why not? Well, the x squared over 4 is fine. You can think of that as 1/4 x squared. But the 5 over x, that's not a polynomial. You cannot have x, or any variable, in the denominator. Two x squared plus 3 divided by x plus 5. Same thing. You cannot have x in the denominator. What about 3 square root of x plus 4x? I don't care about the 4x, that's fine. But that 3 square root of x, you cannot have the square root of a variable. You just can't do that. X has to be raised to non-negative integer exponents. Consider the polynomial 4x to the 6th minus 8x cubed plus 5x squared minus 12. Identify the terms of that polynomial. Terms are separated by addition or subtraction, but we will include the sign. If it's subtraction, we will include a negative sign. So we'll say 4x to the 6th, negative 8x cubed, 5x squared, or negative 12. Those are our 4 terms. For each term, identify the coefficient, or the numerical coefficient, it's sometimes called. That's the number that is multiplied times the variable. So 4, negative 8, 5, and negative 12. There are 3 ways to classify polynomials: according to the number of variables, according to the number of terms, or according to the degree. We'll discuss each of those. So determine the number of variables. 4x squared minus 6x plus 10. there is one variable. 2, a squared b minus 3a cubed b to the fourth plus 7ab. How many variables? 2, both a and b. 4x squared yz cubed minus 5xw to the fifth. How many variables? There's x, there's y, there's z, but there's also w. There are 4 variables. A polynomial with one term is called a monomial. A polynomial with 2 terms is called a binomial. What do you think a polynomial with 3 terms is called? What's a vehicle that has 3 wheels? A tricycle? So it's called a trinomial. Classify each polynomial according to the number of terms. So, 5y squared minus 12y plus 52. How many terms are there? There are 3. So it is a trinomial. 3a cubed minus 5a. How many terms? 2. So it is a binomial. Negative 23x to the 7th. How many terms? 1. It is a monomial. The degree of a monomial is the power of the variable in the monomial. Identify the degree of the monomial. 4x to the 11th, what is the exponent? What power is x raised to? 11. Negative 1/2, y cubed. What's the degree? 3. 3z doesn't have an exponent, so it's understood to be 1. Negative 12 doesn't even have a variable. You know what? Anything raised to the 0 power is 1. So we can pretend like there's an x to the 0 there, and we'll say the degree is 0. The degree of the polynomial is the highest of the degree of any of its terms. So 8x plus 15. The degree of 8x is 1. The degree of 15 is 0. So the degree of the polynomial is the largest of those degrees. It's 1. 3y minus 5y cubed. First degree, third degree. So the degree of the polynomial is 3. 4z to the 5th minus 5z cubed plus 6z minus 1. What's the degree? 5. 10. There's no variable, so the degree is 0. The leading term of a polynomial is the term in the polynomial with the highest degree, and the coefficient of that term is called the leading coefficient. The term of degree 0 is called the constant term. There's no variable, so it doesn't change. So let's complete the table. Our first polynomial, 10x to the fourth minus 7x cubed plus 4x minus 5. What is the constant term? Minus 5. What is the leading term? The one with the highest degree? 10x to the fourth. What is the leading coefficient? 10. And what is the degree of the whole polynomial? It is 4. Our next expression, 5x minus 6 minus x squared. What is the constant term? What is the leading term? Be careful, it's the one with the highest degree. Not the first one, always, but the one with the highest degree. What's the leading coefficient? There's no number in front of x squared, so we use -1. What's the degree? 2. So 15x to the 20th, that's a monomial. What is the constant term? There's not one, it doesn't exist. So we'll put a 0 with a line through it to show that it doesn't exist. It's an empty set. What's the leading term? 15x to the 20th. What is the leading coefficient? 15. And what's the degree? 20. Note that the terms of a polynomial are usually arranged in descending order of degree. Less often a polynomial is written in ascending order of degree. So they're usually written where the exponents get smaller as you go along, but sometimes they're written where the numbers get larger, the exponents get larger. But we're going to choose descending order of degree. That's the standard. So looking at example A, 6x minus 10 minus 2x cubed. We want to start with the highest exponent. So we're going to put that -2x cubed first. Then the next exponent, there's no x squared, but I see an x, so we could say plus 6x. And finally the constant term, minus 10. Can you put this next one in descending order? Which term do you want to start with? 9x to the fifth. What comes next? 6x to the fourth. What comes next? 8x cubed. What comes next? There's no square, but we jump to minus 4x. And last, minus 5. A term with a coefficient of 0 is generally not written and is called a missing term. So looking at this next example, A, 3x cubed minus 4x plus 9, what's the missing term? Well, we start off, the highest exponent is 3. There is no term that has x squared, so that term is missing. We could think of it as 0x squared if we wanted to. It's missing. Then we have x to the first, and finally we have a constant term, which we think of as a 0 degree term at the end. What about this next one? X to the fourth minus 2x. I see x to the fourth. I don't see x cubed. I don't see x squared. I see x, and I don't see the constant term at the end. That's kind of a strange thing to think about, what's missing, but we'll use it later on. Combine like terms and write the polynomial in descending order of powers. So, I like to use some sort of system to identify which terms I've taken care of. So 5y cubed seems to be a term with the highest exponent. Is there another term with 5y cubed? Yeah, 4y cubed. So we have 5 of them plus 4 of them. That's 9 of them, 9y cubed. That is our largest exponent. Our next largest exponent is y squared. I'll put a double line under the y squared terms because they're like terms. I need to combine them, so I have minus 4y squared. What about y? I see two terms that have y in them. 10y minus 12y minus 2y. And last but not least, I have minus 4 minus 6 minus 10. So we combine like terms and we put them in descending orders of power. So our next example, B, we're looking for the highest exponent. Do you see it? I think there's two terms with x to the fourth. That's minus 13, x to the fourth. What's our next highest power? X cubed. I see 3x cubed. I see minus 6x cubed. And don't forget the minus 2x cubed. So plus 3 minus 6 is minus 3. Minus 3 minus 2 is minus 5x cubed. And last but not least, I see two terms that have x squared. 4x squared plus x squared, that's 5x squared. Now let's find the value of 2x squared minus 4x plus 5 when x is 3. If x is 3, everywhere there is an x, we're going to put a 3. So it'll be 2 times 3 squared minus 4 times 3 plus 5. Now we have to follow the order of operations. 3 squared is 9, and 2 times 9 is 18. Exponents first, then multiplication. Multiplication before subtraction. 4 times 3 is 12, plus 5. So now it's addition, subtraction. Start from the left, go to the right. 18 minus 12 is 6, plus 5 is 11. So our answer is 11. Suppose x is negative 2. We're going to write 2x squared minus 4x plus 5, and everywhere there was an x, we'll put negative 2. I find it especially important to use parentheses when I substitute negative numbers into polynomials. So 2 quantity negative 2 squared minus 4 times negative 2 plus 5. Order of operations again. 2 times negative 2 squared is a positive 4. So that'll be times positive 4. Minus 4 times a minus 2 gives us plus 8. Plus 5. 2 times 4 is 8. Plus 8 plus 5. 16 plus 5? 21. And that's our answer. So now we want to find the value of negative x cubed plus 3x when x equals negative 3. Negative 3, once again I use parentheses whenever I'm substituting a negative value into a polynomial. Negative 3 cubed plus 3 times negative 3. Now negative 3 cubed is negative 3 times negative 3 times negative 3. That is negative 27 plus a negative 9. What about that minus a negative 27? That's the same thing as plus a positive 27. So 27 plus a negative 9 gives us a positive 18. If an object is dropped from a height of 600 feet above the ground, its height in feet above the ground after t seconds is given by the expression 600 minus 16t squared. So classify this polynomial in terms of the number of variables. How many variables are there? 1. Classify the polynomial in terms of the number of terms. How many terms are there? 2. And what is a polynomial with 2 terms called? Binomial. What is the degree of the polynomial? The degree is the highest exponent that the variable is raised to. 2. It's a second degree polynomial. How high above the ground is the object after 3 seconds? So t is 3. So we have 600 minus 16 times 3 squared. 600 minus 16 times 9. 600 minus 144. That's 456 feet. If $1,000 is deposited in a savings account that pays compound interest at a rate R, compounded annually, then after 3 years the balance in the account will be represented by the polynomial 1,000 plus 3,000R plus 300R squared plus 1,000R cubed dollars. What is the leading term of the polynomial? The leading term will be the term that has the variable raised to the highest exponent, 1,000 r cubed. What is the degree of the polynomial? 3. Find the balance if r is 0.04, 4% annual interest. So we have 1,000 plus 3,000 times 0.04 plus 300 times 0.04 squared plus 1,000 times 0.04 cubed. Let's put this in the calculator. Just like it is. You can use the parentheses or not. They're not really doing anything in this case. But you'd have to put 1,000 plus 3,000 times 0.04 plus 300 times 0.04 squared plus 1,000 times 0.04 cubed. And if you do that, you should get our answer, 1,120 we're going to round it off to the nearest cent, 54. The polynomial negative 0.8 x squared plus 41.5x plus 898.6 approximates the number of two-year colleges in the United States in a given year, where x represents the number of years since 1970. Use this polynomial to estimate to the nearest whole number how many two-year colleges there were in the United States in the year 1995. Well, if it's 1995 and we need to know x represents the number of years since 1970, then x equals 1995 is how many years after 1970? 25 years. So we want x to equal 25. So we have negative 0.8 times 25 squared plus 41.5 times 25 plus 898.6. Let's put that in the calculator. And we get 1,000 1,436.1 two-year colleges. According to this polynomial, there are 1,436.1 two-year colleges. We probably should just round that off to the nearest whole number. So how about 1,436? Approximately that many two-year colleges in 1995. That's all for this section.